Title of the paper is Effect of Cenosphere and Specimen Crack Lengths on the Fracture Toughness of Aluminium 6061 Silicon Carbide Composites. Main aim of this work is to investigate the influences of addition of Cenosphere and specimen crack length on the fracture toughness of Aluminium 6061 3% silicon carbide composites. Cenosphere is varied from 3 to 9% in the increment of 3% and crack length is varied from 0.3 to 0.6 in the increment of 0.1. The CT specimens were prepared according to ASTM E399 standard for different A by W ratios. From the experimental outcomes, it is identified that fracture toughness of the hybrid composite increases up to 6% of Cenosphere and further increment leads to decrement in the values. It is also found that load bearing capacity and fracture toughness of the hybrid composite decreases with increment in A by W ratio of the CT specimen. The average particle size of Cenosphere used is 15 micrometer and the silicon carbide is 30 micrometer. EDS image shows good bonding of silicon carbide and Cenosphere particles in the Aluminium 6061 matrix. From the graph, it is evident that as the A by W ratio increases, fracture toughness values decreases and maximum result is obtained for Aluminium 6061 3% silicon carbide and 6% Cenosphere composites. Conclusion. Result of the fracture toughness test shows that increment in A by W ratio reduces the fracture toughness of the composite. Increment in the Cenosphere composition leads to increment in fracture toughness up to 6% and further increment leads to decrease in fracture toughness values. The fracture toughness of the 6% of Cenosphere is nearly 6% higher than the 3% of Cenosphere.